Hello student, welcome to the lecture. In this lecture, we are going to discuss the linear combination of atomic orbital principle. Now, in this lecture, we are going to discuss what is a gyrate, ungyrate. There are various terms, that is bonding, in-bonding and anti-bonding. So, these terms are related with some mathematical expressions. Now, let's discuss the linear combination of atomic orbital principle. Now, suppose consider two atoms and B, which have atomic orbital described by function, the wave function phi A and phi B. If the electron covalent these two atom approach to each other, the wave function of molecule that is AB obtained by linear combination is that here we can write that psi AB phi A B. AB is a wave function of molecular orbital of molecule AB. The lambda is a mixing coefficient . Lambda is a mixing coefficient and it measures the ionic character between these two atoms, that is AB atoms. And if these AB atoms are homonuclear diatomic molecule, then the lambda is equal to 1. Now, if suppose when A and B are homonuclear diatomic molecule, then lambda is equal to 1. So, and wave function of molecule we can written as, and wave function of molecule with respect to this lambda is equal to 1 is that we can written as this terms, that is psi AB is equal to phi A plus minus phi B. So this is a terms where the value of lambda is equal to 1 when there is a homonuclear diatomic molecule. If we take an example of H2 molecule, that means H2 is a homonuclear diatomic molecule. Now let's discuss the case or the example of H2 molecule. Which is formed by combination of two hydrogen atoms. And these two atoms we can say that 1 and 5 second. So this will be the two hydrogen atoms represent the wave function of one is atomic orbital of atom A and B, atom 1 and second. There are two different ways of this. Now there are two different ways of combination of these wave functions. The first, the combination of wave functions in two different ways. Way of in the combination of wave function, sine of two wave functions are same, and the second, that is the sine of wave function are different. So when there is a sign of two wave functions are same, then this is called as a constructive interference. And if there is a sign of wave functions are different, then there is a destructive interference. So let's discuss this. The plus and the minus sign determine the symmetry of wave function. Symmetry of wave function. The probability of finding the electron is described by SWAN, and the electron density is described by psi square. That is, if we the wave function have same size, have same sign, then they are in same phase, means there is a symmetry, same phase. Now if you draw that, H1, that is phi 1 plus that is phi 2 . here this is an constructive interference where the atomic orbital have the same size. Atomic orbitals constructive interference. Now let's discuss what is a destructive interference. If the combining wave function of different size, different sign, they are out of phase, that is H1 plus they are in different phase. So now the main product is that is 5 here again 5 minus 5. So this is a destructive interference in that the atomic orbital have a different signs, means that they are out of phase, they are not in same. Discuss the MOT in terms of Gired and ungired. The two ways of combination, of wave function, that is psi Gired and psi ungired, that is G for Gired where U for ungired. This is a symmetry symbol here, that is phi A plus phi second, that is phi 1 plus minus. Then the psi remain unchanged. When we can say that Gired, then the psi remain unchanged. And when there is ungired, the psi changed. The number of molecular automatically produced is equal to number of atomic orbital taking part in combination. Means that when there is a phi 1 and phi 2 is combined, it produces psi 1 and psi 2. Combined, they produce pair of psi Gired plus psi ungired. Such type of subtraction and addition of atomic orbital termed as LCAO. The function of psi is resulting from the combination of atomic orbitals which increase electron density in between nuclei combining atoms. Because this is called bonding molecular orbital. The function of psi ungerade is resulting from the subtraction of which decrease the electron density the nuclei combining atomic orbital and there is a node, so electron density is 0 and called 0. So this molecular orbital is antibonding molecular orbital. So this is all about the wave functions in terms of bond gerade and ungerade. In gerade, that is a formation of bonding molecular orbital, whereas in ungerade there is a antibonding molecular orbital. And we know that the antibonding molecular orbital is generally designated by this asterisk, antibonding distribution. So, in a molecular orbital, can be obtained by squaring the wave function So if that is psi Giroud and psi ungiroud equation, if we get, then if we square that, that is psi 2 square 2 psi 1 phi 2, sorry, psi, that is these terms are generally psi, that is phi. So here that is phi 2 square. Likewise here that is psi 1 minus phi 1 phi 2 plus phi 2 to square. Molecular orbital, that is psi and psi star. Molecular orbital psi and psi star is differ by phi 1 and phi 2. Here in bonding molecular orbital, the electron density increase by an amount that is 2 phi 1 phi 2. So when there is a psi, this is a bonding and this is anti-bonding molecular orbital. So it is also called as a sigma and sigma star antibonding. Means sigma is, that is bonding and that is an antibonding. Overlap of atomic orbital form the sigma bond along the axis. So there is a sigma, that is bonding, and sigma star, that is an antibonding molecular orbital. So let's discuss how the exact formation of S. That is bonding MO, that is sigma Giroud. If that is there is a formation of node, because the sign separation here, this is a plus sign, this is a minus sign, so they are in not in same phase, means they are in different sign. So that's why there is a formation of node, and this is a formation of antibonding molecular orbital. Here it is a antibonding molecular orbital, that is plus and then minus 1. So here formation of bonding and antibonding molecular orbital, bonding and antibonding molecular orbital. So this is all about the linear combination of atomic orbital principle, in that we can see what is meant by the psi, phi, the terms, and they are resulting, how it will be resulting from in the and bonding and antibonding molecular orbital. Now let's discuss the MO energy level diagram. So here in MO energy level diagram, we will take a simple example of combination of two 1s orbital. So let's draw the energy structure. So in MOT, means in molecular orbital energy level diagram, the bonding antibonding molecular orbital shown here, it is antibonding molecular orbital, whereas here that is bonding molecular orbital. In molecular energy level diagram, the atomic orbital are shown in the side, whereas the molecular orbital are shown in the middle or in the center. That is final atomic orbital of one atom, that is Phi2, that is second, that is this is and this is in delta or plus B. Here also plus delta, here minus delta or minus B. So this is all about the molecular energy level diagram. Now let's discuss that term, that is a plus delta and minus delta. That is a plus delta or plus delta or minus delta. That is an energy evolved. Energy evolved. This during formation of bonding molecular orbital, whereas here that is plus delta or plus beta, that is energy absorbed during formation of antibonding molecular orbital. So these are the terms. So here you can write again. The decreasing formation of bonding molecular orbital is known as stabilization energy. Whereas the increasing in energy in formation of antibonding molecular orbital is known as destabilization energy. And this decrease in energy is balanced by the increase in energy. So these are all the terms, that is stabilization energy, destabilization energy regarding with MOT, that is a MO energy level diagram. So we will stop here. Thank you.